Hey everybody, and welcome back to Algebra 2 Online. So the plan for this video is to just do some review problems that'll hopefully get you ready for the upcoming WebAssign quiz on Chapter 6. And just want to start off with this one. It's probably one of the more missed things, as I've said in some of these past videos, but finding the domain of these even roots can be kind of tricky. So this crazy looking root function. You've got a fourth root, a sixth root, and a seventh root. Right now you just gotta worry about two things. There's actually gonna be a third, and it's coming up in a little bit, but you don't have any of those in this unit. So right now, just worry about divide by zero and even roots, okay? So I'm just gonna kind of split the page. We'll do even roots right here. So for the fourth root, right, you just take the inside, set it greater than or equal to 0, you literally just get that part, right? Then for the sixth root, you would have x plus 1, set it greater than or equal to 0, and get x needs to be greater than or equal to -1, right? And then for the, my OCD is kicking in. I want that to be a different color. There we go. For the divide by 0 part, we need the seventh root of 4x squared minus 6x to not be 0, right? If it's 0, we basically are having a conservation of mass issue. Does not make sense. So raise everything to the 7th power, kill that root. Basically that part can't be 0. You can take a 2x out here. You get 2x minus, what would that be, 3 then? All of that can't be 0. And now you've got these nice factors, right? We see that 0 is a root there and 3/2 is a root there. And so those are the, basically these are the two things, I flip my numbers around, that x can't be, right? So if x is 0, right, the bond would be 0, or if x is 3/2, bond would be 0. And so now you just got to combine these two things to say the overall domain of the following function there. And so you basically got these three conditions, okay? And you need x to be bigger than or equal to 0, but also be bigger than or equal to -1, right? And so you always have to take the more like restrictive thing, right? So that means that this -1 case needs to be thrown out. Basically, this root is defined for some negative numbers, right? Like -1/2, but this one's not. And so even though you can plug in -1/2 here, x has got to be the same thing in all four spots. So you can't just go and plug it into one spot and not this other spot where it's not defined. So always take basically the more restrictive domain issue, we'll just say. And in this case, it's the greater than or equal to 0 one. So putting everything together here, basically we get the domain of f of x to be that you have to be bigger than or equal to 0, but x can't be 0, which I just said, or 3/2. So really a better way to say this is x is strictly greater than 0, but x can't be 3/2. That is truly the best way to say it, right? Because no sense saying bigger than or equal to 0, but then you can't be 0. That's silly. So this is how you should say the domain. All right, so another thing that we saw in this unit so far is just these function composition and inverse stuff. And so I've just got another kind of weird looking problem related to that. And it's one of these where you have this crazy long string of functions kind of composed together, but there's something nice in here. So if you look carefully, right, we have a function g and g inverse followed right after each other. So those two should cancel off, right? And so really the problem is g composed with h, composed with f, composed with g again of x. That's what we've got to find, okay? So I'm just gonna kind of start plugging things in. So I'm going to put g inside of f, okay, so this inside of here. Actually, I'll do it this way. going to switch to this notation with the parentheses. I think it'll be a little bit easier. So, so g inside of f, right, would look like you would take a fourth root of 2 times 1/2 x minus 7, right? That's me sticking g inside of f. And this is pretty nice, right, because you've got 2 times a half. So really that's a 1. So really I've just got an x in there, okay? And oops, I need another parenthesis there. So now I'll take h of this fourth root, okay? So this is pretty nice because h is a fourth power function. It's polynomial of order 4. So if you actually go and plug that in, right, you'll kill that root. So we're going to do g of, just mix up the colors here a little bit. So this thing to the fourth minus 6. And like I was saying, this is pretty nice. Fourth root and the 4 there cancel. Again, missed a parenthesis. So then all of that would just become g of, what is that, x minus 7 minus 6, so x minus 13, if I did my math right. And so now I go back to g, right? And the last step is just take half of x minus 13, right? And that is what this big thing would simplify to. But then we were asked, basically, what's the domain of that thing, okay? And this is just a linear function. And so the domain of a linear function is all reals. This is just a linear polynomial. And so it has domain of R, right? There is no domain restrictions whatsoever in that thing. So that is just how you could go about doing that. And I canceled off these two right here, but there is nothing wrong about canceling off those two. Either way, you're going to get G, H, F, G, a composition of those, right? And that's just kind of weird, but you are going to see kind of some examples like that too. All right, so one of the first things we did. All right, so this problem is going back to like one of the first things we did. It looks really scary when you first see it, but I think it's kind of a fun answer to this one. So this is one I would really just recommend you go definitely pause the video and just try to crank through this thing. You have all the skills you need to do this, really any of the problems in this video, but this one's kind of fun if you get it to work out. So it works out really nicely. So hopefully you paused and tried it. I'm going to jump into it right now. Basically, it's just cranking through and bookkeeping with simplifying these root functions. So lots of places you could honestly start. I'm just going to start kind of over here. So I'm going to take the fifth root of all this stuff in here. Okay, so a lot of this I'm just going to kind of copy down, but fifth root of 243 is 3. And then the fifth root of a to the 6, we could just write as a to the 6/5. Fifth root of b to the 10th is actually just b squared, right? Then we'd have c to the 3/5. And so that would be taking the fifth root there. I might even do a little more here. So I'm going to also take the negative fifth power of this stuff, okay? So maybe I'll do some color coding here too. So I'll do this, that was blue. And then, so simplifying this, I could do a to the negative 7/5, b to the negative 1, c to the negative 2/5, right? And then I'm just going to copy over, I'll just copy this over. So negative 4 minus bc over a to the 5th. Okay, and so we know that like if we're multiplying, right, we can add exponents, right? So we have a lot of similar bases. We have a, b, and c, a, b, c. So we can do 6/5, plus a negative 7/5, and 2 plus negative 1, and 3/5 plus negative 2/5. So if we do all of that, I'm sorry, guys. I just realized I messed up my sign here, right? So if you do c to the negative 2, all that to the negative 5, right? Of course, you multiply these things. So I should have gotten rid of my negative there. Negative times a negative is positive, right? Now I think I'm good before I keep going. Yes. So I'm still just going to copy the 4/3, I think, down. No, let's actually do one little thing. So you have a 3 on the bottom and top there, so you kill that, right? So let's just copy the 4 down. And then 6/5 minus 7/5 would be negative 1/5, right? And then 2 minus 1 is 1, so just 1b. And then 3/5 plus 2/5 is 5/5, right? So that's actually just a 1 also, right? And then I've got this thing still that I haven't done anything to. And so if you look at this, it's turning out to be really nice because we know that if we have a negative power, right, that actually is something where it lives on the bottom. So this is really like 4 times BC over a to the 5th, like this part. And then we have minus 4 BC over a to the 5th, right? And so we're subtracting the same thing that we have. And so the whole solution of this thing is 0. That is what that equals. That's a really, really weird way to write 0. Assuming, A, B, and C can't be, there's like domain issues, right? Like A can't be 0 and whatnot. But ignoring those issues, like assuming that A, B, and C are fine for, where they're not going to get some sort of domain issue, then truly this whole expression is 0. All right, so I wanted to show one of these because I think it's kind of a neat example. We haven't seen too much like this. And I'm not going to give you ones like this on the quiz, but I think it's good to see harder examples than what you'll see on the quiz. So a lot of things in the world are not going to be as nice as the ones that you've been seeing lately. You've seen mostly root equations where you have square root and, maybe over here another square root or something. But you could absolutely have square root and then a cube root. You can mix them like that. That's fine. And a lot of the ones where it's mixed like that, you actually do u sub, like we did in chapter 5. And so if I do this kind of thing where I let u equal the cube root of x, then, right, if you cube both sides, notice that u cubed would be x. And so when you do u sub, you're basically looking for ways to introduce this new variable and would kind of help simplify the problem a little bit, right? And so I just basically can take this cube root out and make it just a u, which is really nice. And then if I do that, I just have to make x become u cubed. So I'm going to write this thing as u cubed minus 1 equals negative u plus 1. And I think we would all agree that that's a much nicer equation than the one I gave you, right? Now you just have one kind of root function instead of 2. And that's kind of a common way to pick what u is. You pick it based on giving you a way to eliminate 2 different forms of root functions. Now I just have one and I can solve it, right? So already I got a root isolated. I could just square both sides. And left side would be nice. You just get u cubed minus 1. And then the right side, double distribute that thing out. You'll get u squared minus 2u plus 1. And we're into a polynomial now. So I would just move everything to the left probably to keep the u cubed positive. And so if I move that over, I would get all that. Okay. And now we're just back in chapter 5. And chapter 5 stuff takes over. So I've got 4 terms, and so I would hope you would kind of think factor by grouping, which would be the right thought. You can take a u squared out of that group, and then you could take a 2 out of the second group. And it's one of these nice ones where then you have this common factor. You could pull that u minus 1 common factor out, and you'll have u squared plus 2 left over. So we're seeing that u is either 1 or it equals root 2i. right? Plus or minus root 2I would be the other one. And so these are the three things that u equal. But remember, in these problems, we've got to do this unsubstitute thing, right? So if u is cube root of x, then what we're finding is that the cube root of x equals 1, which that one's really easy to solve. We just get x equals 1. Right? So that's going to be an answer. The other one is, well, I shouldn't say that's an answer yet, right? We got to always check answers on these problems, but it's looking like an answer. Where did my cursor go? So x equals 1. I'm going to just leave that there. And the other one, cube root of x would equal root 2I. Okay, and if you cube both sides, that one, you'll have 2 to the 3/2 I cubed. And we know I cubed is negative I. So actually, I should have given myself a little more room. So I cubed is negative I. Right, that's going back to chapter 4 even here. So that's another possible solution. And then the other one is if the cube root of x equals negative root 2I, right? And so here x would equal negative 2 to the 3/2 I cubed, which is actually pretty nice because I cubed is negative I, right? But then we had a negative times a negative in there. So actually we can just kill that negative and kill that negative. So possible answers are a nice 1 or a not so nice negative 2 to the 3/2 I or a positive 2 to the 3/2 I. And so then, just like any root equation, right, we got to go and plug stuff in. The one we can probably check without much work, because you can see that this is 0, right? And then the cube root of 1 is 1, and negative 1 plus 1 is also 0. So I'm actually going to go ahead and circle that. That one's definitely good. Over here, right, if you, for these ones, it's a little more tricky, definitely. So I guess right here. So I'm going to go and plug this in. So if you go, I'm running out of room here a little bit, but if you go, so I'm just going to take this one, okay, down here. So if you just go to your calculator, and it's kind of weird numbers, but just go plug that in, okay? You will get something that's about 1 minus 1.41i. But if you go do the negative cube root of negative 2 to the 3/2 I, and then plus 1, okay, you're going to get something that's about negative 0.225 plus 0.707i. And so those two things are clearly not the same thing. So this means that this is not a solution. If you do the same thing, but now for the positive 2 to the 3/2 I, this one is giving you a very similar thing, except in this part it's 1 plus 1.41i, and then this one is negative 0.225 minus 0.707i. And so this also is not a solution, okay? Don't think that just because they're weird numbers, that's not a solution for them. Absolutely, you can get these weird answers as solutions for root equations. Just here, they don't become solutions. And that kind of covers it for this video. So, all of these kind of things I think will help you get ready for the upcoming quiz. I tried to pick problems here that I think were on the trickier side, like definitely this domain one, you're not going to see stuff like that tough, but it's good to be able to know how to do with that kind of thing. You will see weird inverse composition problems, but not this weird. And then this is, of course, a very weird looking simplification roots problem that you should definitely be able to do. And then this is not really something that I would ever give you in this course, but I think it's a good one to make sure that you understand how it works, because it really does just pull from stuff we've done. U sub, factor by grouping, even just how to solve a root function, and also some important things with like the checking of the work and stuff like that. So there's a lot going on in this one.